Sorry about the delay. Okay, 3.5 newts. I'm muted. I'm not muted. Testing, 1, 2, testing. Okay, good. Okay, can you hear me? Okay, 3.5, we're going to do maximum and minimum problems. You be quiet, sir. Okay, 3.5. Maximum and minimum problems. So area, let's look at an area problem here. Okay, from geometry. Okay, area. Okay, number 1. We wish to fence off a rectangular area with 20 feet of fencing two sides are up against a wall. And require no fence. Okay, what are the dimensions that will maximize the area? And what is that maximum area? What is the maximum area? Okay, so we have these fences, right? Or we have these walls, and then we have these fences here. Okay, so maybe it's a barbed wire fence. Just make it barbed wire. Keep those crazy people in. Okay, so and we have 20 feet of fencing, right? So we'll say that this is X and this is Y. Okay, so what do we know about the relationship between X and Y? Well, we know a couple of things. We know that the area is going to be X times Y. But we also know that the sum of X plus Y has to be 20 feet. Okay, has to be 20 feet. So X and Y, we're going to add up to 20 here. Okay, so what I can do is I can try to get A in terms of just one variable. So let's say that's X. So if I subtract X from both sides, I get Y equals 20 minus X. And I can substitute this in for Y. So now I have my equation in just one variable. So the area is equal to X times 20 minus X. So you take whatever X is, you subtract it from 20 and multiply it by X, and that'll give you your area. Okay, because Y has to be the difference between 20 and X. Okay, so if I have say that X is equal to 8 feet, then what would Y equal? It would be 12, because 20 minus 8 is 12, right? And then how would I get the area? I'd multiply the two together, and the area would be 96. Okay, so that's just an example using real numbers. Okay, but we want to maximize the area here. Okay, so we want to maximize the area inside. And so what should X and Y be such that we maximize the area? And then what is that maximum area? let's say that this is a of x, because it's now a function of x. A of x is equal to 20x minus x squared. Okay. So now let's find the maximum. Okay, where's the maximum value going to occur? Well, the maximum value is going to occur when the derivative is equal to 0. That's going to give us a critical value, and we're going to get, you know, either a minimum or a maximum there. Okay, and so we're going to say a prime of x is equal to 20 minus 2x, and set that equal to 0. And we're going to say, oh, okay, subtract 20 minus 20, we get negative 2x equals negative 20. Divide by negative 2, and I get x is equal to 10. Okay, so x was equal to 10. Okay, so since y is equal to 20 minus x, then, well, what's 20 minus 10? That's 10. So the maximum area here is created when we have a square. When we have a square, okay, we get the maximum area. We get a 10 by 10 square. And so what's the maximum area? The maximum area is 10 by 10, okay, 10 times 10, which is 100 square feet. Okay, now how did I know that this was a maximum? How did I know that x equals 10 is a maximum? Well, I could look at values on either side of 10. Okay, I could look at, say, plugging in maybe 9 and 11, okay, into this. I would end up getting, you know, for f prime, or sorry, a prime of x. Okay, at 10 it's 0, right? So that's the whole idea here, is that if I plug in 10 for x, I would get this equal to 0 for 10. Now I want to know, well, what happens at 9 and what happens at 11? Well, if I plug in 9, that's 20 minus, looking right here, okay, right here. Okay, 20 minus 2x. Okay, so that's going to be, 9 is going to be positive 2, and then 20 minus 22, that's negative 2. And so it goes from a positive to a negative, and positive slope to negative slope will give me a maximum. Now, the other thing that we know about this function, the original function, is that this is a quadratic and it's a parabola. And this parabola looks like this. And so right at 10, where the vertex is, right at 10, we get the maximum value, okay? And the maximum value there is 10, so 10 times 10 is 100. Okay, so you could do this without calculus if you knew the properties of a quadratic formula, but I'm just going to use the calculus to get my critical value, and then that's going to tell me what the maximum area is. Okay. Okay, let's move into the business realm. Okay. Let's do revenue here. Okay, we want to maximize our revenue. Okay. Okay, number 2. In order to sell X units of a new phone, the price per unit in dollars must be, okay, lowercase p of x is equal to 1,000 minus X. Okay, so X units, so the number of X units. Okay, so the price depends on how many units I'm producing. More units I produce, the lower the price. Okay. So every unit I produce lowers the price of the phone by $1. Okay, so now this is, if I produce 1,000 units, it's not going to be $0. So there is going to be a floor here, but in this case, we're not worried about that floor. Okay, because we don't care about what's going to produce the lowest amount of money. We want to know what's going to produce the highest amount of money. Okay. Okay, the cost. Okay, the cost of producing X units will be will be what? C of X is equal to 3,000 plus 20X. Okay, so 3,000, that would be my fixed cost. And 20X is called my variable costs. Okay, so this is saying, hey, I need $3,000 worth of material to make these things, but then I also need $20 worth of material for each phone. Okay, so I need $3,000 worth of equipment, and then $20 worth of parts to make each phone. Okay, and the more phones that I sell, the cheaper they become. Okay, it cost me 20 bucks to make, so I want to maximize my profit here. Okay, it cost me $20 to make, and I'm going to sell the phone for like, I don't know, $300. That's a lot of profit. Okay, but I also have to take into account my fixed cost here that I have to pay off over time. Okay, so this is, this is called overhead usually. Okay, that's my overhead, and this is my parts. Okay, so we want to know, well, what's my profit function here? Okay, how many units? Well, let's ask the question first. How many units must be sold in order to maximize the profit, and what is the price per unit? Okay, what's the price per unit? Okay, so basically we want to know what is X and what's 1,000 minus X. Okay, how many units must be sold? That's X, and then what's the price per unit? That's 1,000 minus X, right? Okay, so and we may even want to know, like, well, what's the total profit that I make? Okay, it's the price per unit, and how many units must be sold in order to maximize the profit, and what is the price per unit? I'll put and what is my maximum profit, or what is the maximum profit? So what is the maximum profit? Okay, so let's figure out, well, what's our profit function first? Okay, so what's the revenue going to be? What's the revenue? Well, the revenue is the price times the number of units. Okay, well, the price is dictated by how many units I sell, right? So 1,000 minus X times the number of units. Well, the number of units is X. So the revenue here ends up being 1,000X minus X squared. So now what's my profit function? My big P of X is my profit function. That's going to be my revenue function minus my cost function. So the revenue we saw was 1,000, that's 1,000, 1,000X minus X squared minus my cost function, which was what, 3,000 plus 20X? So now I'm gonna say, well, the profit function, I'm gonna clean this up a little bit. This is gonna be minus 3,000 minus 2X, or minus 20X. So this is gonna be, I'll go negative X squared. Okay, we'll go in descending order. And then it's 1,000X minus 20X. Okay, I distribute the negative sign, I get a negative here, and I get a negative here. Okay.
980X?
Yeah, exactly. So that's 980X. And then I've got minus 3,000, right? Minus 3,000. Okay, so this is my profit function. Okay, and so what do I want to do? Well, I want to maximize this profit function. So once again, this is a quadratic. It's an upside down quadratic. And so we can do the same thing that we did before. We're going to find a maximum on this value. Okay, at the end, it's an upside down quadratic. How do I know it's a quadratic? Because it's a second power. How do I know it's upside down? Because it has a negative in front of the X squared. So it flips the whole thing upside down. So I want to take P prime of X. I'm going to go negative 2X plus 980. And I'm going to set that equal to 0. I'm going to say, oh, okay, negative 980, negative 2X is equal to negative 980, divide by negative 2, and X is equal to 490. Okay. So X is equal to 490. That's the number of units that I need to sell. The number of units I need to sell to maximize my profit. Okay, so 490 units need to maximize my profit. Okay, what's the price? What's the price per phone? Okay, we'll say this is the optimal price per phone. Optimal price per phone. Well, that's 1,000 minus 490, which is $510. So optimal price per phone is $510. So there's your new iPhone right there, or your new Samsung. Okay, so it cost them $20 in parts to make a $510 phone that they're going to sell at $510 to maximize their profit. Okay, and so what is their max profit on 490 phones? Well, the profit function of 490, that's negative 490 squared, right? Let's go back to the profit function. That's negative X squared plus 980 times 490, okay, and then minus 3,000. Okay, so I plug this all into a calculator. Let me share my screen here. Sharing the screen. Okay, if I plug this into a calculator, I will get 490 squared. I'll make that negative. Okay, so that's negative 240,100. Okay, and then 980 times 490. 980 times 490 is 480,200. Okay, and then minus 3,000. I'm going to plug all of this into the calculator. So let's clear that. out, I'm going to get 240, 100 negative plus 480, 200 minus 3,000. Okay, and I get $237,000. $237,100. $237,100. Okay. That's my max profit. Max profit, which comes from selling 490 phones at $510. Okay, so if I sell more than that, then due to my price function, okay, because my price function was kind of weird. It was just a limit. This is my price function right here. It starts at 1,000 and then goes down. So if I sold 1,000 phones, I would make nothing. Okay, for whatever reason. So we know that, you know, somewhere around the middle here, at 490 phones, okay, I'll end up getting my maximum profit. So this is my price function. Okay, I could have my revenue function, which is a parabola. Okay, I could have some sort of revenue function there, and then we have a cost function as well. Okay, so maybe the cost function, it starts out at, this is 1,000, right? The cost function starts out at 3,000 and then goes up from there. Okay, that's the cost function. It's actually linear because it goes up 20. Okay, and so then we find some sort of profit function. Okay, and the profit function says that at, I'll put the profit function in a different color because it says, look, at 490, the profit function is going to have a maximum value. Okay, so this is my profit function, and it's going to have a maximum value of 237,100. So this thing goes way high. So let me just think of it like we're at 1,000 here for that value, but it's really doing this. It's really okay. It's really, yeah, way high.
And the red line is the demand curve?
The red line, there's two red lines. I'll change one of them. So there's no demand, there's no supplier demand here. Okay, this is just the red line is the price function. Okay, this was, say, P of X, little p of X. Okay, the price function, right? Okay. If I wanted to talk about the revenue function, it would be P of X times X. That's the revenue function, which is R of X. Okay, that's P. I'll say R of X is equal to. We'll put that in a different color too. I'm running out of colors, but okay, R of X is equal to X times P of X, right? So, and that would be this function up here. The revenue function would be this guy here, okay? Which is really, that's a parabola that goes through 500 is the vertex on that one. So the vertex on this one is 500. Okay, and then I don't know what the height is on that one. It's going to be whatever 1,000 times 500 minus 500 squared is. I could figure that out. So 1,000 times 500 minus 500 squared. 1,000 times 500 minus 500 times 500. That's 2,250,000. So that would be the revenue at the this would give me the max revenue basically, because again it's just a parabola. It's an upside down parabola, and so if we were at 500, okay, we would be slightly higher because this was 237, and we would be slightly higher for our revenue function. But this one would be completely symmetric. About okay, this one would be completely symmetric. Okay, and that would be at 250. Okay, that's the revenue function. That's the max revenue. But then we have to take into account the cost function as well, which is this green line. So we'd have to subtract the blue minus the green, which is the cost function. Okay, and then we would get this purple function, and we want to find the maximum of the purple function. The purple function is the profit function. Okay, so the profit function there. I guess I should put that circle in purple. Okay, so you can kind of see how these things, you know, work together. You know, if you were to graph them all, it might get a little confusing, especially since we have 4 graphs superimposed on each other. We might just want to focus on 2 of them. We might not even care about the cost, and we might not even care about the price per unit. Okay, we might just care about the what do we want? No, we could care about we might not even care about the revenue, because the revenue is so incredibly close to the there we go. Okay, so incredibly close to the revenue is so incredibly close to the profit function that, you know, and that's really what we want to focus on, is the profit function. Okay. So, yeah. Wrong color. Give me the right color. Okay, and that occurs at 490. Okay. So, yeah. If we didn't have any cost, if it was just all revenue, if we didn't have any cost whatsoever, then it would be 500. And it'd be 500 would be the number of units that I would want to sell. Right, it would maximize my profit. But we did have cost in there, and that lowered it by $10. I'm sorry, that lowered the number of units by 10 units, and it increased the price of the phone by $10. Since I'm selling less units, I need to make up for the price on the back end. Okay. Okay, let's look at another pricing model here. Okay, number 3, a theater. Which, do those even exist anymore? I don't know. I think they've all gone out of business. Okay, a theater. What? And they're like, this is what my grandchildren are gonna ask me someday. They're like, "What's a theater?" I mean, people actually went to a physical place to watch a movie. I'm like, yeah, it was really weird. And it's like, well, why wouldn't you just put your VR headset on, watch a movie that way? I don't know, because that's what we did in the old days, right? We went to these big places, and they're like, "Well, that just seems so unsafe, Grandpa." Like, I don't know what to tell you. So
That's how they got Lincoln.
Exactly. Exactly. I think there's another one who died in a theater too. Like uh, of the like 45 presidents, I think 2 of them died in a theater. Lincoln was one of them.
Was it
So
George Washington?
I don't know. You can look it up. I mean, and being president, by the way, is like the deadliest job on the planet. Since there's only been 45 guys that have had that job, and 8 of them have died in office, like you have a 20% chance of dying on the job, which is pretty scary. So, yeah. Okay, a theater determines that, again, this is a very outdated example since we don't have theaters anymore. Okay, a theater determines that a ticket price of $26 averages 1,000 people in attendance. Okay, so you're charging 26. That's a pretty pricey ticket. Maybe this is like not a theater ER. Maybe it's the theater where RE where people go see plays and stuff. You know, maybe it's like the theater instead of the movies. So. A theater determines that a ticket price of $26 averages 1,000 people in attendance. Okay. For each $1 discount, it gains 50 more customers. Okay, it gains 50 more customers. What price should the theater charge to maximize the revenue? What price should they charge to maximize revenue? Okay, see what we got here. Okay, so what's the revenue? The revenue is going to be the price times the number of units or the number of tickets sold, right? So price times the number of tickets sold. Okay. So let's let N equal the number of $1 discounts, $1 discounts given. Okay. So okay. So what's the ticket price? Well, the ticket price, the price is going to equal 26 minus 1 times N. Okay, this is the number of $1 discounts, right? If I give $3 in discount, then that would be a $23 ticket. Okay, so which is just 26 minus N. Okay. Okay, what about the number of units? Well, how many units are going to be sold? Well, how many tickets? I'll just say tickets. Okay, number of tickets sold. Well, if N is 0, then we're at 1,000, right? So we're at 1,000 tickets sold. So 1,000 tickets sold. But if N is 1, then we go up 50. If N is 2, we go up by 100. If N is 3, we go up by 150. So this would be 150. This would be 50 times N. Okay, would be equal to the number of tickets that I'm selling. So what would be the revenue here? R of N. Okay, R of n is going to be 26 minus n times 1,000 plus 50n. Okay, I want to take the derivative of this and set it equal to 0. Okay, well, let's just do the product rule. Okay, let's take the derivative and the product rule. Okay, so the derivative of the first is the derivative of negative 26, which is 0, minus n, which is negative 1, so it's negative 1, times the second, plus the derivative of the second, that's 50, times the first, 26 minus n. Okay, so now let's simplify this, distribute and simplify. This is negative 1,000 minus 5n plus 50 times 26. Okay, is 1,300 minus 50n. So 1,300 minus 1,000, that's 300 minus 55, or sorry, yeah, 300 minus 55n. Okay, I don't want to set that equal to 0. Did I do that right?
Professor, wouldn't it be 50n instead of 5n?
Yes, thank you. Thank you. Yes. 50. Yeah. 50. There we go. Thank you. Yeah, something wrong there. So this is minus 100n. Okay, so I'm going to add 100n to both sides. So I'm going to get 300 is equal to 100n. Divide by 100. Divide by 100. And so n is equal to 3. So I'm going to give 3 discounts. Okay, so what's the price per ticket? Okay, the price per ticket should be $23, right? 26 minus 3, so it should be $23. Okay, gaining a maximum audience of what? Well, what's 350s? That's 150. So the maximum audience of 1150. Okay, and taking in a maximum revenue of whatever 23 times 1150 is. 23 times 1150 is $26,450. Okay. Okay, let's do our last example here, which is a very big example. So try to get this done under a half hour, but we'll see. We'll see what happens. Okay, so basically it's a 2-page example. So, but it's a staple of business calc, so I have to cover it. You haven't taken business calc unless you have taken this problem. Okay, so and it is called inventory cost. Okay, inventory cost. So let's do example 4 here. Okay, Fred's Electronics sells 2,500 televisions per year. Okay, to reorder, its inventory, a fixed cost of $20 plus $9 a set is charged. Okay, it costs $20 to store one set for a year. Okay, so the question is, how many times should the store reorder how many sets should be in each order, and to minimize, I have an and here. And okay, so how many times should the store reorder and how many sets should be in each order to minimize the inventory cost? Okay, so this is a pretty hard problem. Okay, takes a lot of thought, but it's really not too bad. Okay, once you figure out what you're dealing with, it shouldn't be too bad. But it is rather challenging to kind of the naked eye of somebody who doesn't know what they're doing. Okay, so let's try to gather all of the inventory costs here. What's the inventory cost? The inventory costs involve the storing cost plus the reorder cost. Okay, so the reordering cost and the storing cost, those are the two costs that are involved here. Okay, so we know that 2,500 sets will be sold. Okay, we need our lot size. Okay, our lot size. Okay, to be X. Okay, this lot size is how many in each order? That's what we really want to know. How many in each order and how many orders? Okay. Okay, so we need to know how many will be held in stock. Okay. How many sets should be held in stock? Okay. So let's take the extreme example here. Okay, let's take the extreme example that we order all 2,500 sets. Okay, we order all 2,500 sets at the very beginning of the year. Okay, so we have one order of 2,500 sets. Right? Okay, so what's the average amount of televisions that I'm going to have on hand, okay, throughout the year? Well, the average amount of televisions that I'm going to have on hand throughout the year, that's going to start at 2,500. Okay, and then it's going to slowly decrease over the period of 1 year to 0. Right? So this is 1 year, 365 days. I'm just going to put 1 year. Okay, so it's going to slowly decrease over a period of 1 year. Okay, so in the beginning of the year, I have a lot more storing costs, and at the end of the year, I have a lot less storing costs. And if we were to look at the middle here, we would see, okay, or what we call the median, okay, we would see that the amount here, okay, or really what I should be focused on is the amount here. The lack of televisions at the end of the year is equally offset by the increase of televisions at the beginning of the year. Does that make sense? Those two green lines are the same. Okay, if I order all 2,500 at some point in the middle of the year, after 182.5 days, okay, I will have exactly 1,250 sets on hand. And so it doesn't matter. It doesn't matter. So on average, I will always have 1,250 sets, or x over 2 sets, okay, on average. Okay. Does that make sense? So whatever I have in my inventory, right? The average of all of my inventory is going to be this, just take the order size and divide by 2. Okay, so take my lot size, divide by 2, and that's how many I'm going to have on hand on average. Okay, on average, I will have 1,250 sets on hand. Okay, some I'll have more in the beginning, which will increase my storage cost, and I'll have less at the end, which will decrease my storage cost. Okay. Get rid of that guy. Okay, but this may not be the optimal setup. The optimal setup may be to have much smaller orders. Okay. We don't know. Okay, what if we, instead of had a lot size of 2,500, let's have a lot size of 500. Then what does that mean? That means that throughout the year, I would have to have 500, right? 500. I would have to have 5 orders of 500, right? Because what's 2,500 divided by 500 is 5. This is the number of reorders. Call that N. Okay, that's the number of reorders. Okay, if I did 2,500 divided by 2,500, which is the lot size, I would have 1 order. Okay, 1 order. Here I have 5 orders. Okay. Okay. So at the very beginning, I'm going to have 500 sets, and then it's going to go down to nothing. Then I'm going to reorder, and then I'm going to have 500 again. It's going to go down to nothing. And then I'm going to reorder again, and then it's going to go down to nothing. And then I'm going to reorder again, and it's going to go down to nothing. And then at the very end of the year, I'm going to reorder one more time, and it's going to go down to nothing. Okay. So on average, how many sets do I have in my inventory on average? Well, once again, I just look at the median and see how the area here fills in this area, and this area here fills in this area, and this area here fills in this area, and this area here fills in that area, and this area here will fill in that area. And so on average, I will have exactly 250 sets on hand. 250 sets on average. That's the average amount that I have to pay to store, right? Sometimes I'm paying for more sets, sometimes I'm paying for less sets, but on average, my storage cost is just going to be my lot size divided by 2. Okay, so let me write that out. The storage cost is how much does it cost to store these things? Costs $20, right? $20. Okay, the storage cost is $20 for whatever my lot size is divided by 2. So this is X over 2, okay, for the year. Okay, because I'm not keeping as many on hand. Okay, I'm reordering. However, there is a reorder cost. Okay, and this is going to be the number of times I have to reorder. So the number of times I have to reorder, well, that's 2,500 divided by X, my lot size, right? So it's the number of times I reorder times the cost of reordering. Okay, so it's the number of times I have to reorder times the cost of reordering. So, okay, so number of times of reordering, 2,500, times the cost of reordering. Well, what's the reordering cost? Well, the reordering cost is the 20 plus 9, right? $20 plus 9, right? So $9 per set. So this is $20 for like gas, I guess. I don't know, like using the truck, plus $9 per set. Well, how many sets? Well, that depends on how big the order is. Okay, so the reorder cost is this guy. So now I know what my total cost is. Okay, total cost. Total inventory cost is going to be my storage cost, which is 20 times X over 2, which is really 10X, right? So isn't this really just 10X? Okay, the storage cost is just 10X, where X is my lot size, right? So 20 divided by 2 is 10. So the total cost is 10X, which is my storage cost, plus, okay, we'll do 2,500 over X times 20 plus 9X, where again, X is the lot size. I want to find out what is the optimal lot size. It's going to minimize my inventory cost. Okay. I'm going to call this I sub X for inventory cost. Okay, so maybe I'll just call it inventory cost. Okay, is going to be 10X. Maybe I'll distribute this guy. I don't know. Okay, because I'm going to have to take a derivative in a second. So 20 times 2,500, that's 50,000 over X. Okay, plus this is going to be 2,500 times 9, X over X. The X's are going to cancel. That's kind of cool. So that's just 2,500 times 9, which is 22,500, 22,500. Okay, good, good, good. Okay, so now I want to take a derivative of this. I'm going to set it equal to 0. Okay, and let's see. Okay, what this thing becomes. This becomes 10 plus, this is going to be negative 50,000 over x squared. Okay, remember what the derivative of 1 over x is? It's negative 1 over x squared. I just put the 50,000 in front because it's a constant. It's a coefficient. Okay, plus 0. That's my derivative, right? My derivative. Okay. So now I'm going to set this equal to 0, and I'm going to solve. Okay. So I have 10 minus 50,000 over x squared is equal to 0. I'm going to do something a little sneaky here. I'm going to multiply both sides by x squared. And I get 10x squared minus 50,000 is equal to 0. I'm going to divide by 10, get rid of that 10. And I get x squared minus 5,000 is equal to 0. Right? Okay. And then move that over, and we get x squared equals 5,000. And then we take the square root of both sides, plus or minus. We get x equals plus or minus. Okay. I could simplify that if I wanted to. I'm not really going to. It doesn't matter. I need real world numbers anyway. Now, what's this minus thing? Well, that would be negative televisions. I don't want negative television, so I'm going to drop the negative. That has no, that doesn't have a real world application to it. But, oops. Okay, but the square root of 5,000 does. Okay, so x is approximately, if I take this square root of 5,000 and then take the square root of that, it's about 70.7 sets. Now this is a problem. 70.7 sets. Okay, now I can't order 70.7 sets. Okay, I either have to order 70 sets or 71 sets. Okay, for each of them. Okay, so to minimize my cost here, my inventory cost. So I either need to do I of 70 or I need to do I of 71, and I want to find out what is this? Okay, what was my inventory cost function? It was this one here. And I want to find out which one's the lowest one, which one's the minimum here. Okay, so if I order 70 sets at a time, okay, then my inventory cost is 10 times 70. Okay, get that for reference there, plus 50,000 over 70 plus 22,500. Okay, so this 22,500 is kind of negligible because it's always going to be there. And now, or I want to compare it to 10 times 71 plus 50,000 over 71 plus 22,500. Okay, and if I plug all of that into a calculator, okay, I will get 23,914.29 for 70. That's the total inventory cost for the year. Okay, if I plug in 71, okay, if I plug in 71, I will get I will get 23,914.23, 6 cents less. I think I could probably eat the 6 cents, but it's all good. Okay, so that's 6 cents less. And just to prove that this is the minimum, if I went up to 72, okay, or even down to 69, okay, these would actually be bigger. Okay, so 72 would be a larger amount. 72 ends up being 23,914.44, so that's larger than the 23. And I don't know what 69 is. I haven't calculated it out. We don't really know, but it is bigger. It's bigger. so this one is the winner. The 71 is the winner. Okay, so now, okay, that's how much should be in each lot size, sort of. Okay, now again, the real world is messy, right? The real world is messy because if we get 71 in each reorder, right? So again, we're going to start off with 71, and then we're going to go down, and then we're going to go to 71, and then we're going to go down again, right? 71 to 0, and then when we get out of inventory, we're going to keep reordering, right? So I want to know, well, how many times do I have to order this thing throughout the year, right? How many orders do I have to make? Orders, okay. How many orders do I really want here? Okay, number of orders. So what's 2,500 divided by 71? Well, that goes in 35 times with a remainder of 15 sets left over. Okay, so 35, if I divide 2,500 divided by 71, okay, I get 35. But I get a certain remainder left over. This is, okay, 0.21 blah, blah, blah of 71. So, well, what is the remainder? Well, let's do 71 times, clear. Okay, 71 times, oops, stop. Okay, 71 times times what do I want? 35. That's what I want. 35. Okay, is 2,485 sets. So if I only order 35 times of 71, I would only have 2,485 sets, leaving me with 15 sets shy. Okay, so I wouldn't get all my sets. So what do I have to do to compensate for these 15 sets? Well, I have to bring an extra set over at some point. Okay, so the answer to the problem, how should I reorder, what's the optimal way of reordering here, is that since I have 35 orders, okay, throughout the year of 71, but I need 15 extra sets to come over, then of this 35, 15 of those orders I'm going to have to include one extra set. So 35 minus 15 is 20. So I need 20 orders of 71 sets and 15 orders of 72 sets. And that is the optimal way of ordering these sets. Okay, so again, you will have one like this in the homework. Okay, I don't think you're going to have one like this on the exam. Otherwise, it would take you a half hour to do one problem. But again, you're not a business calc student until you've had this problem. So congratulations, you are now officially a business calc student. Okay, so again, the real world is a messy. Okay. Okay, I'm good. I'm done. I'll see you guys on Tuesday.